Good morning. My name is Jerry Ball, and today I'm going to be talking about type shifting and overriding in double R grammar, two key mechanisms of context accommodation. This research was conducted in collaboration with Stuart Rogers of the Institute for Defense Analysis. Double R grammar is a computational cognitive grammar of the grammatical analysis of written English. It is focused on the grammatical encoding of referential and relational meaning. It is cognitively and linguistically motivated. It adopts the incremental and interactive language analysis constraints on human language processing. It's pseudo-deterministic in the sense that it pursues a single best path, but is capable of accommodating the evolving context. It is construction-driven in that constructions that correspond to lexical items determine the grammatical analysis capabilities. It is large scale and functional, and it is focused on meaning determination. Double R grammar is a descendant of proposition model, which was based on my doctoral research from 1985 to 1991. It was implemented in Prolog, programming logic, which proved to be inadequate for several reasons. For one, there are no probabilistic mechanisms and no type hierarchy in Prolog. The unification-based pattern matching is very powerful, but there's no matching to higher level types. It involves strictly serial execution of logic clauses based on file order, and it couldn't handle the considerable ambiguity of natural language. In 2003, the original research was ported to ActR5. Basically, logic clauses became productions in ActR, and facts became declarative memory chunks. ActR5 has probabilistic mechanisms and a type hierarchy, which were lacking in Prolog. Chunks are organized into a type hierarchy, and the parallel chunk retrieval uses base level activation and spreading activation across matching types and results in retrieval of a single chunk. Production matching occurs in parallel also and uses the type hierarchy, so you can match at different levels in the hierarchy. And the single matching production with highest utility is serially executed. This version of double R grammar was used in the development of a synthetic teammate capable of analyzing text chat from human teammates and piloting a simulated UAV or drone. Here's a view of the computer hardware used in the synthetic teammate project. It involved a simulated UAV reconnaissance task. You see that task on the left. A synthetic pilot that interacted with two human teammates, a navigator and a photographer using text chat. And it was implemented in ActR5. And you can see on the right that we actually re-implemented the GUI and Lisp to support interaction of the synthetic teammate. The model was empirically evaluated at the end of the study, and overall performance of teams with a synthetic pilot was not significantly different from all human teams. In 2015, double R grammar was ported to Java ActR, the version of ActR developed by Dario Savucci, for a follow-on to the synthetic teammate project. There are several advantages of Java ActR. For one, it was compatible with the latest version of ActR, ActR6. There are lots of good Java programmers. GUI integration is easier in Java than Lisp. I can vouch for that myself. And we borrowed Java-based code to support spelling correction using the edit distance algorithm, and we used Java-based regular expressions for perceptual bypass mechanism, which basically involves tokenization. And we also use Java to implement some tree diagram code. This was done by Stuart Rogers. However, there are some disadvantages of Java ActR. For one, there's limited support for this non-standard implementation of ActR, and most of the ActR community uses standard Lisp version. In addition, any Java-based functionality is not within the ActR cognitive architecture. In terms of current capabilities, the written word recognition subcomponent of double R grammar has about 100,000 words and multi-word units in its mental lexicon. This number is in line with estimates of the size of the human mental lexicon, and it was created with a combination of automated and manual techniques. There are also about 70 parts of speech organized into multiple inheritance hierarchy, and currently the model is capable of handling about 50 prefixes, 120 suffixes, and uses about 40 morphological analysis productions to do this. There are also about 35 lexical retrieval and perceptual bypass productions. The perceptual bypass uses Java-based regular expressions for tokenization under the covers. Spelling correction also is used and involves some Java code based on the edit distance algorithm. The system now has a single and double shot learning capability for the learning of lexical chunks for unknown words. We recently achieved a 98.5% part of speech tagging accuracy rate, which is competitive with state-of-the-art machine learning and deep learning systems. This result was reported at Virtual ICCM 2023. In terms of grammatical analysis, there are about 150 different grammatical chunk types corresponding to grammatical constructions, and about 2,000 grammatical analysis productions, which were manually created and tuned, but are linguistically motivated. These productions cover most of the common grammatical constructions of English, like declarative clauses, WH and yes/no questions, imperative clauses, etc. They also handle intransitive, transitive, and ditransitive and situation complement predicates. We also handle the active versus passive alternation and the indirect object versus recipient alternation. And we handle different forms of nominal, including possessive nominals. Also, conjunctions and punctuation are handled by the system. There are also some more specialized constructions like the comparative, focus, and subject extraposition constructions. The grammatical analysis capabilities are approaching the breadth and accuracy of leading machine learning systems. So in ACTAR 6, a capability the support for chunk types was made more flexible. In particular, it was made possible to dynamically change the type of a chunk and to dynamically add or remove slots from a chunk. These changes made a type shifting mechanism possible. Previously, we were only able to override a chunk with an alternative chunk, but now via type shifting, we can avoid the need to override chunks. There are some downsides from overriding. For instance, if you override a chunk that is already integrated into a higher level chunk, then you need to adjust the pointers from the higher level chunk to point to the alternative chunk. And if the chunk that's overridden has instantiated slot values, these may be lost unless appropriate instantiated slot values are copied from the overridden chunk to the alternative chunk. So why do we need type shifting and overriding at all? Well, if you accept the well-established cognitive constraints on human language processing, which include incremental and interactive processing, it is our claim that the need for type shifting and overriding follows. For instance, given incremental processing, that means there is no parallel access to the right context that is being processed. And if you assume interactive processing, it means that you need to use all available information to make the best choice given the current input and current context. However, the locally best choice may not turn out to be globally preferred. And for this reason, you need to accommodate the evolving context. And we call this context accommodation, which is non-monotonic because it may alter the representation. And two key mechanisms of context accommodation, the focus of this presentation, are type shifting and overriding. Overall, processing in double R grammar is pseudo-deterministic in that we make the best choice given the current input and context, and we assume that choice is correct and proceed incrementally forward, but we accommodate the evolving context. So we're going to talk more in detail about the type shifting and overriding mechanisms. So type shifting changes the type of a chunk without replacing it. The instantiated slot values remain and higher level pointers to the chunk remain. So type shifting is preferred to overriding when only minor adjustment is needed. For example, to convert a predicate intransitive verb construction to a predicate transitive verb construction, which adds an object argument slot. On the other hand, overriding replaces a chunk of one type with an alternative chunk of a different type. Any instantiated slot values must be copied to the alternative chunk or they will be lost, and higher level pointers must be shifted to the alternative chunk or they will be incorrect. Overriding is preferred to type shifting when types are significantly different. For instance, if you have a lexical noun that you want to type shift to an object referring expression or a nominal, the differences are substantial, and overriding will be preferred over type shifting in that context. Likewise, for a lexical verb, which needs to be type shifted to a verbal predicate construction. So type shifting involves a change to the type of an existing chunk. If we look at the example, John began the book. In the mental lexicon, the verb began is only included as a verb that prefers an object argument. So when began is processed, it will project a predicate verb object construction, a transitive predicate, when it is incrementally processed, and subsequently the object referring to the book can be integrated as the object argument of that predicate verb object construction. On the other hand, in John began reading, began can also combine with a situation complement with a progressive or infinitive verb form, e.g. reading or to read. So when reading is incrementally processed, we need to type shift the predicate verb object construction to be a predicate verb ing situation complement construction, so that reading can be integrated as the ing situation complement. Here's a representation for the input John began the book. And we were using the Java-based tree diagram tool implemented by Stuart Rogers. It's important to note that the value of a slot in Act R, if it's a chunk, is actually a pointer to the chunk. It's not the actual chunk itself, although these diagrams hide that reality. So some of the examples of constructions, we have a declarative situation referring expression construction at the top level, a proper noun object referring expression, and a predicate verb object construction. And we also note that in these representations, we have grammatical functions. So we have a specifier, a grammatical function, a head grammatical function. And this is one of the more unique features of representations in double R grammar. It's important to note, since these chunks are not directly integrated, for them to be accessible to type shifting, the chunk needs to be in a buffer or would have to be retrieved somehow. So the representation for John began reading shows that the pred verb object that is preferred with began has to be type shifted to be a pred verb in ing situation complement, so that the situation complement corresponding to reading can be integrated as the value of that grammatical function. You'll note that in the processing of reading, we actually projected a ing situation referring expression that has a subject and an object argument, where neither of those arguments actually occur in the input and therefore are implicit. So we can look at another example of an ambiguity in English that supports the need for type shifting, and that's the apostrophe S in English, which can either be a possessive marker or an auxiliary verb. So in John's book, the apostrophe S is a possessive marker, and in John's going, the apostrophe S is the auxiliary verb is. With type shifting, we can choose one and accommodate the alternative. Alternatively, we could have a composite part of speech category, possessive marker, or auxiliary, but the problem with that part of speech category is that the meaning of the possessive marker is considerably different from the meaning of the auxiliary verb is, which is an argument against having a composite part of speech category. Apostrophe S is actually even more ambiguous in that when it's an auxiliary verb, it can either be the auxiliary verb is or has. In the expression John's gone, it is ambiguous, which is intended, but the default preference in double R grammar is the auxiliary verb is. And it may require fine-grained meaning to disambiguate which meaning is intended. So if you say John is gone, the is in John is gone indicates that this expression is inactive. Where inactive is the intransitive equivalent to a passive expression like John is giving me the book. On the other hand, if we say John has gone, then has is an active auxiliary verb, and the expression has an active meaning, unlike the inactive John is gone. So there's a difference in meaning between John is gone and John has gone, but determining which is appropriate in any given context may require access to fine-grained meaning that we don't currently represent. As another example, the expression, the taxi's waiting, he's blowing his horn. In this expression, the apostrophe S is the auxiliary verb is, which is consistent with the default preference. And this default preference is reinforced by a subsequent present participle blowing. So in English, we can say he is blowing, that's fine, but he has blowing is not really grammatical in English. So when apostrophe S is followed by blowing, the strong preference is for that apostrophe S to be the auxiliary verb is. On the other hand, in the taxi's waiting, he's blown his horn, the apostrophe S is better mapped to the auxiliary verb has. So in the context of a past participle blown, we need to type shift the lexical chunk from auxiliary verb is to has. And since both are lexical chunks, type shifting is preferred in this example. And a question we can ask is, has preferred over is when followed by a past participle? This is an open question at this point, but we don't have the empirical evidence to decide one way or the other at this point. But you can say he has kicked the ball, which is a passive construction, and you can also say he has kicked the ball. And if you say he's kicked the ball, it's unclear what the preference should be. So overriding involves overriding an existing chunk with an alternative chunk. In the expression John is running, the intransitive verb running will be integrated as a predicate head without projecting a predicate construction. This happens because in double R grammar, we build the minimal structure needed. We don't build unnecessary structure. On the other hand, in John is running fast, where fast modifies running, we now need access to the predicate intransitive verb construction so that the adverb fast can be integrated as a modifier. So in this case, we need to override the lexical chunk running with the grammatical chunk predicate intransitive verb. We need to shift the lexical chunk from being the clausal head to the predicate head. And this combination of overriding and function shifting is very similar to adjunction in tree adjoining grammar. Since the lexical chunk is already integrated, we need to adjust the pointer from the higher level chunk to point to the predicate intransitive verb construction instead, which means that the higher level chunk must be accessible. So if we look at the representation for John is running, you can see that the verb running is directly integrated as the head of the declarative situation referring expression. On the other hand, for John is running fast, we now need to insert a predicate intransitive verb construction as a head overriding the intransitive verb, and then we need to shift the intransitive verb from the head of the clause to the head of the predicate intransitive verb construction. And then the adjective adverb fast is integrated as a modifier of that construction. As another example of overriding in the expression John is running a marathon, in this case, we need to project a predicate verb object or transitive verb construction so that the nominal a marathon can be integrated as the object of running. In this case, we also need to override the lexical chunk with this grammatical chunk, and we need to shift the lexical chunk from clausal head to predicate head. Since the lexical chunk is already integrated, we need to adjust the pointer, and again, that higher level chunk needs to be accessible. So in this representation, we see that the predicate verb object construction overrides running as the clausal head, and the intransitive verb running is integrated as the predicate head, and the object referring expression a marathon is integrated as the object grammatical function. As a final example of extreme overriding, consider the expression John's sad. This is a clausal expression in which the adjective sad is integrated as the lexical head of a situation referring expression, and the apostrophe S is represented as the auxiliary verb is functioning as a specifier. And we see the representation for this here, where you have an auxiliary verb is functioning as specifier and a lexical head sad functioning as clausal head. On the other hand, for the expression John's sad story, where we simply add the noun story after sad, we get a very different representation. In this case, the adjective sad is functioning as a modifier of the noun story within an object referring expression. In addition, we need to access an object head so that the noun story can be integrated as a head and the adjective sad as a modifier. We also need an object referring expression in which the object head can be integrated as the head. We need a second object referring expression, and this object referring expression can be type shifted to be a possessive object referring expression in which the auxiliary verb is type shifted to possessive marker and integrated as a possessive marker, and the possessive object referring expression is integrated as a specifier of the higher level object referring expression. And importantly, the higher level object referring expression must override the situation referring expression for John's sad. So there's a lot going on here to make this context accommodation. And here's the resulting representation, where you can see at the top level we have an object referring expression with a specifier grammatical function that's filled by the possessive object referring expression John's, and then we have an object head with a modifier sad and a noun story that functions as a head of the object referring expression. Now, the important point to note is there's no obvious processing difficulties for human in making these extensive adjustments, which suggests the need for context accommodation. In particular, there's no garden path effect, like in the example, the horse raced past the barn fell, which stumps most readers who are unable to make the adjustments in this case because the adjustments are just too radical. But what if the expression is already integrated? So if we have if John's sad story is integrated, and I think John's sad story is coming to an end, we also need to adjust the higher level pointers when we do the overriding, and we need to copy appropriate instantiated values from the overridden chunk and remove inappropriate values. Otherwise, there's a risk of losing previously instantiated values and also a risk of having inappropriate values. In sum, In summary, context accommodation is needed given well-established cognitive constraints on human language processing, in particular, the incremental and interactive nature of human language processing. ACTAR 6 and the Java ACTAR implementation provide architectural support for type shifting and overriding. And we prefer type shifting for minor changes to chunks, and we prefer overriding for major chunks changes which motivate creation of an alternative chunk. Although the examples in this presentation are somewhat unusual, the need for context accommodation is actually very common. For instance, many intransitive verbs can be used transitively, like John smiled a big smile, and many transitive verbs can be used transitively, as in John kicked Mary the ball. And that completes my presentation, and I thank you for your attention.